Suppose you're an engineer on the Death Star. Lord Vader has asked you to determine how the energy density inside the super laser changes if he adds a 0.1 meter wide amber plate with a dielectric constant of 2.6 because he wants to turn the laser red instead of green for added Sith effect. The super laser is actually a relatively simple capacitor with two plates that are separated by 2 meters and has a potential difference of 166 volts. Describe to Lord Vader how this addition will alter the electric field and therefore the energy density of the super laser. So the first thing we need to do is to calculate the energy density in the electric field at our original capacitor without the placement of the amber plate. So the first thing we do is we find our electric field as it currently sits. So we have E is equal to negative delta V over delta X, where delta X is the distance between the two plates, and our delta V is given in our problem statement of 166 volts. So you get that delta E is equal to negative 166 volts over 2, which is equal to negative 83 volts. Then we move over to calculate the energy density. We find that energy density is equal to 1/2 times epsilon naught E squared, where E is just the E that we calculated over here. And so we get that our energy density in our original condition is 3.048 times 10 to the negative 8th. The second thing we need to do is calculate our delta V and our electric field in the condition where we have added the amber plate. So the first thing we need to do is calculate the electric field inside of the insulator, in this case the amber, and we get that by looking at the applied field over the dielectric constant. In that case it's negative 83 over 2.6, which gives us 31.923. The next thing we'll use that and we'll calculate delta V air, which is just the 83 volts from our applied field times the amount of distance that isn't taken up by the insulator. In this case, the insulator is 0.1 meters long, and so this is just 2 minus 0.1, and that gives us 1.9. So we find that delta V air is 157.7. Delta V amber is that 31.2923 times the 0.1, which is the width of the insulator, gives us 3.192. Gives us delta V net is those two numbers added together, giving us 160.89. We use that to calculate our electric field, again the negative delta V over delta X, just like we did before, except this time we're using our new delta V net, which is negative 160.89 over that same 2 meters, gives us negative 80.44. Then we calculate the energy density of the new condition with the amber plate, 1/2 epsilon naught times E squared, where epsilon naught and 1/2 are the same, and then our new E value we calculated, and then that gives us 2.864 times 10 to the negative 8th. Overall, if Darth Vader wants to look cool, he will be sacrificing a small amount of stored energy.